This is the second type of problem and the third video in the series for speed of light calculations. We already talked about the speed of light formula and we solved for wavelength. So we're going to focus on example number 2 right here, solving for frequency. This is again page 36 in your notebook, and we're going to get started. Example 2 says solving for frequency, and it does say what is the frequency of radiation with a wavelength of 5.00 times 10 to the negative 8 meters. Just like before, I'm going to list the symbols or the variables for the problem. Speed of light, wavelength, frequency. We always have the digit or the value for the speed of light. 3.00 times 10 to the 8 meters per second. This time we have the wavelength. It says what is the frequency? So I'm going to put a question mark in there for frequency, and I'm going to take this value 5.00 times 10 to the negative 8 meter. I am going to look at the speed of light formula. C is equal to lambda times frequency, or nu. And I need to rearrange again because I need V alone. These two are multiplied, so I'm going to divide both sides by the lambda to get V alone. And I am going to rewrite that formula because there's a lot going on right there. So, sorry about that. V, or nu, or frequency, is equal to speed of light divided by lambda, or wavelength. I'm all set up to solve for frequency, so I'm just going to do an additional equal sign, make my divide line, and plug in my variables, or my numbers for my variables. So C is equal to this value, 3.00 times 10 to the 8 meters per second. And the wavelength in this problem is 5 times 10 to the negative 8 meters. Just like last time, I am dividing a fraction into a fraction. I'm going to make them both actual fractions and multiply by the reciprocal. So 3.00 times 10 to the 8th meters over or per second times the reciprocal of this. This is a number, so we know they're always over 1. So the reciprocal is going to be 1 with the value on bottom, negative 8 meters. Use blue. Our units here, numerator, denominator, they cancel out, which is good. I'm not looking for length this time. This time I'm looking for frequency, which should come out in per seconds. I have to consider significant figures again. We are dividing 3.00 times 10 to the 8th divided by 5.00 times 10 to the negative 8. So I'm going to look at the coefficients and tally up how many sig figs each number has. They both have 3, so I can report 3. I need to report 3. I should re-say that. 6.00 times 10 to the 15 is what I got. This second is on the denominator side, so I'm going to do per second. If we take a look here for frequency, as I said last time, it's the number, so 6.00 times 10 to the 15 per second. So our units came out well, which gives us an indication we did it right. And I just solve for frequency using the speed of light